Hello students, in this video we are going to discuss counters. So as the name itself indicates, so we are going to perform up counter and down counter. So the counters are broadly classified into two types. One is asynchronous counter, another one is synchronous counter. Okay, so before going to discuss asynchronous and synchronous, we will discuss what is the counter. So this is the block diagram of positive edge of the clock of counter. Okay, this is a negative edge of the counter. How to find out? As I said before, so if you are assigning the bubble right at the back end of the clock pulse, so it is a negative edge of the clock pulse. So if you are not assigning any bubbles, so at the back end of the inverter, okay, so it is a positive edge of the clock pulse. Okay, so usually in order to count either it is up counter or down counter, we need the clock for both synchronous and asynchronous. Okay, and we will get the n bit output based on a number of flip-flops or requirement. If it is a 2-bit counter means we need 2 flip-flops. If it is 3-bit means we need 3-bit flip-flop. Okay, so now we will move to the types of counter. We have two types of counter, as I said before, asynchronous or ripple counter. Here the clock pulse depends on the previous flip-flop outputs. So here the input and outputs or the flip-flops are not synchronized with the single clock pulse. We call that one as a asynchronous or ripple counter. All the flip-flops are synchronized with the single clock pulse means it is a synchronous counter. Okay, in your CA2 exam for the 2 marks they will ask compare synchronous and asynchronous counter. Okay, here as I said before, in the asynchronous the flip-flops are not clocked simultaneously, right? In the synchronous counter all the flip-flops are clocked simultaneously. Okay, so in the asynchronous, as the flip-flops are not synchronized globally, so it produces the delay at the output. So because of propagation, we call that one as propagation delay. Here the propagation delay is very minimum in the synchronous counter. Speed of operation is very slow, speed of operation is very fast in the synchronous counter. Here very few logic circuits are required to implement a synchronous counter. So the designing of a synchronous counter is very simple when compared to the synchronous counter. In the synchronous counter, we required many number of logic circuit and also it is very complex to design. Asynchronous counter is very cheaper than the synchronous counter. Synchronous counter is very costlier than the ripple counter. These are the um, difference between the asynchronous and synchronous counter. The main difference is in the asynchronous counter, all the flip-flops are not synchronized simultaneously. In the synchronous counter, all the flip-flops are clocked simultaneously. Okay, that is the main difference between the synchronous and asynchronous. Now we will discuss one asynchronous counter. It is a 2-bit asynchronous or ripple counter, right? So we need two JK flip-flop. Here in order to perform up count or down count they are using the JK flip-flop, right? So here the input of JK is always I. Here we are using two JK flip-flops, so the input of J and K is always the difference is the clock pulse. See here, in the first clock pulse, we are giving the global clock. Okay, the first flip-flop is triggered by the clock signal, but the second flip-flop is triggered by the output of the first flip-flop, right? So this is the main difference when compared to the shift register also. See here, here JK input is always high for both the flip-flops. Only the clock varies. For the second flip-flop, we are giving the output of the first flip-flop. So for example, so as it works under the negative edge of the clock, it is a rising edge of, falling edge of the clock. Okay. So at the falling edge of the clock, your QA, this one is a your LSB, this is your MSB. Okay, so QA is LSB, QB is your MSB. Initially, all the flip flop stores 0 0, right? So for the clock pulse, the falling edge of the clock pulse 1, okay, so it triggers the J and K both are 1 means toggle output, right? Q is equal to 0 means it toggles as a 1 for the first clock pulse. But for the first clock pulse, JB and KB both are 1s, but the clock pulse is yours. You are receiving as a QA output. What is the QA output? It is a 0, right? So if it is 0 means your 0 means it becomes 1, right? So only during the rising falling edge of the clock pulse only your output toggles. For the positive edge of the clock pulse it won't toggles. Okay, it won't toggles. It retains the same state. It retains the same state. It won't toggles. For the falling edge of the second clock pulse, the QA get toggles. This is your one. Again, for the negative edge of the clock pulse, it toggles to 0. Right? Now my QA output shifted to the QB. Right? So now it is toggles because now it is a falling edge for the after the second clock pulse. For the third clock pulse it triggers, okay, at the falling edge of the um, clock pulse, okay, at the falling edge of the clock pulse. So now my previous state is 0, my current state, right, it is 1. So again my QA output is 0, right? So it won't toggles because QB also receive the same value, so it won't at the positive edge, so it retains the previous state. So up to fourth clock pulse we will receive 00011011, which means this is your clock pulse. So we are assigning, so 00 for the first clock pulse, for both the flip flops, so 00 over second clock pulse, third clock 10, fourth clock pulse 11, right? It counts from 0 to 3. So up counter it counts from initial value 0 to 2 to the power of n minus 1, 2 to the power of n minus 1. Here n is the number of flip-flops. Here the number of flip-flops are 2. 2 to the power of 2 means 4. 4 minus 1 is equal to 3. It counts from 0 to 3. Right? So in your exam, design 2-bit up counter or explain asynchronous 2-bit up counter means you have to write some theory along with the block diagram and timing diagram of the 2-bit up counter. So in the next video, we are going to discuss asynchronous down counter and synchronous up and down counter. Thank you.